So I don't know if this will go into a video, but I am out here at the St. Paul RC Club field with my university project, working from home in double quotes. Um, and I'm going to do a test flight. I was out here yesterday and was mostly successful, but ran into a few little glitches that I believe I've tracked down and fixed since yesterday, so I'm back out here to try again. This is all our home brew or in-house autopilot. And I've been doing a lot of code changes over the last two and a half weeks since I'm stuck at home. So it was a good time to get coding. But the weather's getting nice out here. You can maybe see the windsock is not doing too much, and it's nice and sunny. So I'm the only one out here, so I pretty much have the field to myself. I have my proper social distancing of 6 miles from the nearest human, maybe. So that's what I'm up to today. I'll see if I can get some video of the flight, maybe, as well. Okay, the plane is all set to go. We're out here in the field pre-flighting it, doing the controls checks, and I'll do the power check. The ground station all looked good. I used the SIGAR acronym, so that's controls, instrumentation, gas, in our case throttle, area. I give the area a good look around, make sure there isn't anything going on out here. No airplanes in the area or anything else to worry about. And then R is for radio, which typically in full scale you would call and tell people what you're doing. But in this case, I use it to remind myself to turn the onboard camera on. So, or check it if we're doing aerial surveys. I'll check that the shutter's working, the camera's powered. I hear that nice little click when I flip the switch. Okay, the plane is up and flying. Just have my cell phone here, so it's not going to be super exciting. There we are. It's holding 200 feet and just doing a little circle hold. And that's it. Okay, so I just sent the airplane up to 350 feet above ground. So I thought this might be an interesting time to just do a quick tour of our little ground station here. This is also developed in-house. It's designed to sort of mimic a Cessna 172 panel, but obviously tweaked for UAV use. Yeah, just real quick. Left to right across the top we have our annunciator bar, and everything's green pretty much, which is good. So we have a number of satellites. EKF, that's our navigation filter, or the thing that figures out our roll, pitch, yaw. So it's good that that's green, because that's a critical part of the control loop. Then we have our battery voltage, and that's per cell. So it divides the cells for you. 3.99 volts, or divides the total voltage by number of cells, and saves you doing some math in your head if you're switching between airplanes with different amounts of cells in their battery. I don't have a milliamp or an amp meter on board, so 100% battery is fictitious. And then we have our flight timer, which is 6 minutes and 30 seconds into the flight. The link button says we've got good radio link between the ground and the air, and vice versa. Both are talking to each other. The auto button says we're on autopilot. The next thing is the wind estimator, saying the wind is from 200 degrees at 3 knots. And the outside temperature is 15 C. So it's actually nice sweatshirt weather. Okay, that's the enunciator bar. And then going across from left to right on the top row, we have our little avionics voltage, which is just right around 5 volts where it needs to be. And then the per cell voltage, which is the main battery, and that's right around 4, depending if the motor's running up or down right now. So we have an 8,000 milliamp battery in there, I believe. So we can actually fly well over an hour under good conditions. The next thing is the airspeed indicator, and that's actually reporting in knots, just because I wanted to do it that way. You can see there's a little speed bug right at 25, and that shows the autopilot target, and we're wavering up and down a little bit, but there's a little thermal activity, and we're going through a circle, so it's not quite locked in. The little orange needle below is the estimate of true airspeed. So the white needle is indicated, and the orange is our best guess at true airspeed or over ground speed. Well, no, true airspeed. Then we have our little attitude indicator, and this shows us we're in a left bank and pitched up around 5 degrees, give or take. And then we have our altimeter. The little red mark there just above the 9, that shows ground, so it's 912 is what it's technically here. So that's whatever the GPS thought the ground altitude was when we powered on. And then we have a little altimeter bug for the little needle, and that shows us our target altitude, and we can see it's holding it pretty stably. And we're, if I do the math, 350 feet above ground. Then over here we have our power indicator, and again, that doesn't say anything because we don't have an amp sensor on this airplane. The turn coordinator is left there because that was on the Cessna 172, but it really doesn't tell us any good information for a UAV. The more interesting display here is our heading indicator, and this is our EKF heading. So it's showing our true heading is the white needle. The wind estimate is the blue needle that's spinning around, so it's basically saying the wind is coming mostly out of the south. And then the orange needle is our ground track. So it's actually trying to line up the orange needle with the heading bug. You can kind of see the heading bug there. It's just a little to the left of top. And so it's accounting for the wind. It's crabbing into the wind properly depending on if it's going crosswind and which way, upwind, downwind, all that. So typically when you see us coming here now, if you look at the blue arrow, we're right around downwind. And we don't have perfectly high frame rates here, or update rates on the data. So it's not perfect. And then we have our vertical speed indicator, which we're holding level. It seems to be doing okay, and it's really stable, so that means I'm going to go check that data and make sure that number is actually flowing through correctly. So that's a quick tour of our instrument panel on our ground station. So you may have noticed that our ground station is actually a web page, and we have 3 tabs you can open up, and the second tab you can open up is a map. So this is just showing top down our flight status. Shows us doing this left turning 90-meter radius circle about the center of the blue dot. The black dot that you see that it's just about to pass over, the black circle, is our home location, and we set that. I walked the airplane out to the point where I want it to land, and I went on the ground station here and said, make this home, and so it does that. We can also load a map layer, a satellite image layer from Bing, so we can do that. It's just hard to run the interface here while I'm holding the camera. We still have that same status bar across the enunciator bar across the top. And we can right-click on this map. Let's see if I can do this. I'm going to just right-click, and we can bring up a menu of things to do. So we can circle here, wherever I have right-clicked on the map. We can move our home position there. We can bring up a window to land the aircraft, or a dialog box that will enter a bunch of fields to specify how we want the airplane to land. We can set airspeed, we can set altitude, we can run a calibration, we can do a test, we can, this has a system for flying routes where you draw the outline of the route and the ground station can save those for you. And you can manage those as projects. And then there's some other settings. So that's just some of the basic things you can do there. Okay, last but not least is our property viewer. And this is basically all the variables that we're sending from the air to the ground. They're mimicking what the airplane is tracking on board. It's sending messages down and they're being populated here in this property tree. And we can actually see them changing live. So you can see like the numeric value of the actuators, some of the autopilot stuff, like its target airspeed, is changing ground track target, the text system, which is sort of a blending of airspeed and altitude and throttle and elevator, that's running, so we can see some of those numbers. There's some stuff about communication, the comms. There's a sequence number which helps us track if a message from the ground station has been sent up and received correctly. And also we use that to make sure that our link is solid and it's kind of like a heartbeat. We have some information here that we just requested from the plane when we started up, and we said, hey, what's your mass, what's your max speed, your min speed, your weight balance for the text system. There's a better name for that, but I'm not thinking right now. Call signs, specs. Now here's like our navigation filter. That shows up as EKF on the annunciator bar right now. So we can see like our gyro biases, our accelerometer biases, and then roll, pitch, yaw, things like that. We've got wind estimate, all kinds of stuff. Here's like sensors, air data, GPS, IMU, some other status stuff, some things about the task that we're doing. We're currently doing a circle task. So that's it. Okay, so we are 46 minutes into this flight and still going strong. Sorry for the glare there. Holding 350 feet above ground. Still doing our circle. We're at about 3.7 volts per cell on the battery, so we still have a fair amount of time we could fly if we wanted, I believe. Okay, we had a good flight. I didn't film the landing because I wanted to be a responsible safety pilot and be ready for manual takeover in case anything happened. But we had a good landing. We overshot a little bit, but it was a fully autonomous landing. So now I'm all loaded back up in the van, ready to head home, and I thought I should sign off and just give a little summary. We flew for 1 hour, 17 minutes, and 21 seconds. So I don't know if that's my all-time record, but it's really close. It's maybe a tie, give or take a few seconds. So that's pretty cool. That's on an 8,000 milliamp hour 4-cell battery. This thing just putters along. There's a lot lot of thermals today up there. The airplane was reacting quite a bit to up and down, but it's designed to do that. So it all went really well. The only thing that I noticed that wasn't quite right is the temperature coming through on the air temperature from the airplane wasn't coming through on the ground station and getting displayed correctly. So that's probably a typo somewhere. I gotta go track that down. So that's that. We had a good day. Everything's in one piece and safe and hopefully good data. See you next time. So while I was out flying, someone fired off a model rocket, and I caught a bit of it on video, and so here is the best of my low-tech video editing skills to show that. Just a little dot. And there it went. Super exciting, huh?